This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known. So welcome everybody to the Math Map Book Club, where Kirsty Gilpin and I discuss a booklet each week from our Math Map curriculum used by the Classical Conversation students enrolled in community. And today is December 10th, 2025. So we're winding up the new year, and I'm really just grateful for those of you that are hanging in here during the holiday season, so that when the families join us again in January and get really active, they have some work prepared for them, or some help, I should say, prepared for them, from our conversations. So, Kirsty, what are we doing today?
So today we have some more questions that have been submitted. So just a shout out to Babs because she reached out and invited people to share their questions. And so we've got some good ones this week. First, however, we're using this as a chance to kind of give you sneak previews. And so last week we talked about the two new flashcard decks that are coming in April. And we also now can give you a preview of our Math Manipulatives kit. And so on the left, you see a great image of what to expect in that kit. And on the right-hand side is a list of what will be included, and also the specific games or activities that they were chosen to correspond to. That's certainly not a limiting list. So this is a starting point because we know that, for example, you could use a compass in several lessons. You could use the geoboard in several lessons. You could use different things in many different ways. But these were some specific activities or games that these items correspond to. So you can see where exactly you could, as a starting point where you could use those. So we're excited. We had a number of families come by our offices this summer to try out various different configurations of the kit, various different types of compasses and origami paper and patty paper and so forth. And these were the ones that were the favorites. These were the ones that had the best feedback. So we want you to know it wasn't just us picking them, but we invited families with kids in to give us some feedback that was really helpful. And so, does anybody have anything they'd like to say or question about the Math Manipulatives kit that's coming?
What are the place value sets? Is it just like is it solid or is it like paper, cardboard?
They're solid, they're plastic, and it's basically like the unit cubes and the 10 rods. You may have heard them called that somewhere else. So that's what that is. So you have a cube that represents 1,000, square blocks that represent 100, and then you have your 10 cubes in your unit, or your 10 rods in your unit cubes. Um, And we will be adding more support to the companion for manipulatives. So that will be something else that will roll out next year, is a little bit more support. And over time, that will grow. So as you can see, we're continually trying to improve the resources that we're providing to go along with the lessons. So we're excited about this one. We've been talking about it for a long time. So it's nice to see it finally making it from the conversation out the door to being available for sale.
Yeah, I wanted to echo Kirsty's enthusiasm, especially the number of times we had families come practice. The children just really enjoy talking to each other while they're doing math and using the hands-on tools. And truly, it's a social event, not a solitary event.
All right. So here's our first question that was sent in. Is how are the tops of the lesson pages organized in such a way that makes completing only the tops a viable way to tutor, or other tips for just doing the top? So I'm going to invite Lee to chime in first because I know that she really designed this believing, and I just want to clarify, Lee, that when you say a great way to go through this is by doing the tops, tailoring it by doing the tops. You're not talking about every year, but really that first year through, that this is a way to introduce yourself. So I'm going to go ahead and turn it over to you.
Yeah, so two things. One, remember we are designing this for classical conversations communities, and the tops, and then some lessons it's the sides, are where the images are, and that is a place where through our training we can help our tutors focus on the big ideas. So the children and the tutor have an image with some sort of function, graph, grid behind it, and then there's some sort of equation associated with it. And that's what makes it so that you can go through those and get a good idea about just the, high level what's going on in that lesson. I don't necessarily agree that you would, what you just said, Kirsty. I think you can do it that way. But what some people may find is the tops, especially on some of the ones that are really function heavy, may feel overwhelming. And you might actually want to have your students go through the bottoms of those lessons or do it at page 1, 5, 9, 13 process in order to actually still get the gist of what the lesson is. And then maybe the second year, go concentrate on the tops. But it doesn't, and that's the thing about the math map, you get to pick. But when the first year you go through a curriculum, you don't know yourself how everything's going to work. It's not possible for us to tell you that. And so it is a good strategy, like Kirsty said, to go through the tops, and that might be all you get, those weeks. And then next time around, do the tops and the bottoms of the page. But that's just one of many strategies, and you can go back through all the videos Kirsty's done. There's just reading the pages, there's copying the pages. There's just so many ways to start. So in a lot of ways, the tops really were for conversation that could be guided in the seminars of challenge.
Well, that's a great reminder that that was one of the driving needs in CC when we first sat down and talked. I know that that was one of the things that you really saw a need for, was a unified conversation in community, because no other curriculum really allows you to both tailor the curriculum at home and work at a pace that is challenging yet accessible for a student while still staying on pace with your community. And so Lee was really trying to make it so that everybody could be talking about the same thing every week, yet tailoring at home to their individual homeschool needs. I
The
think
other thing I want to add too about the community aspect, I mean, just a quick tip. So if I was tutoring a seminar of a challenge, probably maybe more challenge 1 and 2, I might just go around the room and say, okay, if I have 12 students, I'll say, okay, you're at the first graph on page 1, you're the second graph, you're the third, you're the fourth, flip the page, you're the fifth, you're the sixth, you're the seventh, you're the eighth, and then have each of my students tackle one of those problems, all different from each other, and then bring in that conversation of, okay, what was hard, what was easy, what was familiar, what do we have to practice this week, what did you not even know how to do at all? If you couldn't do anything, did you trace first at least? Did you go ahead and try to look at the chart? Like, so it gives the tutor a place, so they don't have to pick each week, and particularly when they're new to the curriculum, they don't even know really what's in it. So by saying just go through the top problems, it gives them a place to begin too. That's pretty inclusive. So there's a lot of ways to use them in seminar.
one thing that I think he did a great job in the first dimension lessons, and it carries through to the other dimensions, but maybe is less obvious, was that idea that you wanted to combine words, symbols, and images.
Mhm.
And so when you said that about, particularly thinking about lesson 11, where you have the graph and then all of the sort of related analysis that goes along with that, that where we look at that, those graphs really are the primary images that we're looking at, the symbols that describe those graphs, and then whatever words that go along with that. And so that's a great model for us as we're talking about that with our students, to make sure that we're thinking about how do these words, graphs, and images work together, and that is giving us this dimensional idea where we look at the tops. What are the big graphs? What are the big images that are related to those dimensions, to give our students that peg that they can hang on to as they're thinking dimensionally. That's one of those ideas to really help them to see what are the commonalities among those page tops. Um, so
Yep.
we don't want people to only do the tops for 13 years. That's not our goal. But it certainly is a great way to tailor if you're looking for a place to maybe do a little bit less on the page, but
Mhm.
allow the conversation to go more deeply.
Mhm. Yeah, and we know weeks 11, 18, 25, and 26 all practice those same functions across their tops. And we know that those are going to be that's where the analytical geometry is. That's where the calculus is. And those are going to be things that are more unfamiliar. So it might be if your children are challenged 2 or 3 and you're doing it for the first time, you actually want to spend the time on those tops because you know you won't have many years to go over them. Right. So, everybody's strategy is going to be different with the tutors and the seminar and how they use those tops, whether it's superficial, because, like the Polygon booklets, that's very restful. Those aren't particularly hard at all. And so that might be a time where a tutor says, yeah, let's go ahead and everyone look at the tops, but we're only going to spend 10 minutes this week, not the whole hour on it.
Thanks. Does anybody have any experiences that they'd like to share with looking at the page tops?
One thing I found, we had one week that was particularly full with other things going on, doctor's appointments and stuff. And so I was like, okay, let's just do the tops with my 9-year-old when fractions. And we literally knocked out 8 pages of just the tops in less time than it took us to do 4 full pages. And so I was like, well, that was kind of weird. Okay, so tomorrow let's do the 9 through 16. And we did that again, super fast. And I was like, well, we still have time. Let's try knocking out the bottom portion of the first 8 pages. And we did those super fast too. I don't know if there's something brain-wise where if you just do the tops of the pages, I found that it actually helps my 9-year-old get them done faster. But we still have like we still are able to get um great conversations, and it's not just like checking the box, getting the page done, but actually I feel like the understanding was even deeper by doing the tops and then going back and doing the bottom pages. I don't know why.
Yeah, well, because familiarity breeds speed, and you got to kind of watch for that, right? Because it's called the rule. If you have 2 thes in a sentence, you only see one because your brain goes so fast. And so the familiarity, if it is simple, or the familiarity can help it feel simple, so you can go faster. But then you got to watch and say, oh, but well, let's check for careless error. So what you said, I think, is true, but it also can fool us into how well we actually know the material. It's good.
And it's a great way to also have a strategy to switch things up when your week is a little bit different, or maybe your student's struggling, and to say, hey, we're going to just approach this differently this week. That too can sometimes be helpful. Thanks. All right. So here's another question that somebody sent in, and they shared that they'd heard the idea of looking at a narrower domain as being a good way to tailor, and they wanted to know what was it that we envisioned for students accessing the booklet. And then they went on to make a bunch of suggestions, which are really what probably we had in mind. But I'm going to let Lee address that and what she was thinking when she designed the curriculum that way.
So this question has a whole lot of questions in it, so I guess I'll just go through them, one by one. Um, so she's suggesting that, what you just said, to go ahead and tailor and by going to a narrower domain. And I liked how she used that word. That was really great, that it's narrower. So what I see a student doing is bringing in, so let's do 2 students, one where it's their first year and one where maybe they've been at it for a while. So in that first year, um, you go ahead and you buy say you're an A, you buy the complex book. And a few weeks in, your parents may say, wow, you're really struggling, and I'm not quite sure how to help you. Let's just together tonight read the naturals lesson. And that might be enough. Or if it's not enough, then you might say, okay, that was great. We read that. I think we need a little more strength in this area. Tomorrow, I'll print off the first 4 pages of fractions from the compass, and we'll go through those 4 pages. Now let's finish what we can in the complex book the next 2 days. I mean, that's one way that you can do it when you're just starting. Another way to do it is you just go, okay, we really just struggled with complex in challenge A. So let's just do it again in challenge B. You know, you'll bring the complex lessons in, the tutor will have the challenge B book, or the, not challenge B, monomials. But and some students, I bet you, we're going to have complex, and some are going to have monomials, right? That you're not going to be the only one who necessarily struggled with the material. And so, what we have a hard time with in American education is really believing that repetition is okay. That, you know, our child somehow not, you know, progressing in academics. And yet we know darn well you do not become a good baseball player if you do not swing the exact same way thousands of times. So that's just like a cultural attitude that we have to get over. So by having the mapping in the book, so whether you make a copy, like she asked, of some of the siblings pages, we really do ask that you know, keep that in community and in family. Do not share with community. You know, the people like Babs and the folks helping here need their salaries paid, and we know as Christians the workman's worth of wages, and the Ten Commandments say, "Thou shalt not steal." I know that the digital era has kind of gotten, you know, that cultural attitude away from folks. But you know, feel free within your family to use cross using the booklets. And then she's asked here, should we just buy a narrow domain to have it on hand? Um, you could. I would say more like if you got to lesson 4, 5, 6, and 7 in complex, you were just really struggling. Sure, put the complex totally aside. Like I said, you'll use it the next year when you go into challenge B and go by, you might not even want to buy reals. You might want to go 2 levels back or narrower and buy, what's before reals? Just went on my head. Rationals. Is that correct? Yeah, rationals. So, and then the non-printable interactive version in the math map, you know, doing things online, our younger folks are probably more used to it than we are. That was not designed for the children to do that way. It was designed for the adults. But that doesn't mean that you don't have an occasion where a student who is competent can look at the screen and work to paper, and look at the screen and work to paper. People forget that the physical control of your body and the eye, you know, using your eyes from another source to a piece of paper adds to careless errors. And so that's why we don't recommend that as the normal way of doing your work when they're, you know, younger. Challenge 3, 4 students might be very adept at that. But with the younger ones, make sure they have written materials that they can write on in front of them. And then, of course, there's the people that want us to make it non-consumable, which is fine too. Just put a page protector on it if they're really young and having difficulty with the transferring of problems. This is what you could do sometimes. Just transfer problems to paper and don't bother solving them. No, that's what you're practicing, is the transferring of the problems. Right? So you could transfer the problems one day and then just solve them the next day. This is the thing that we forget about children, is they don't have the complex experience in various pedagogies and body and mind control that adults do. And breaking the task into those plus ones is really a good thing to do rather than too much at once. So that was probably more than you wanted me to say, but that's what I thought of.
So I'm just going to kind of recap what Lee said, just some things that people may need clarified, because you're right. She did use that word narrower, and for those parents who maybe are going, what does that mean? I thought I would just draw a quick picture here of. Let me turn my pen on. If we think about, right, as a funnel. Right. All of my complex numbers might enter into the funnel, but then some of them are going to spill out once we get to reals, right? Only the reals can go through here because and without getting into the terminology of how we compare different infinite amounts, right? I'm not going to say there's more complex than there are reals, but there are complex numbers that are not real, so they would get filtered out. There are numbers that are not rational numbers, right? And so they would get filtered out. So notice that what's happening here as I go down, I get to my integers and some of those right? So like my imaginary numbers are getting filtered out. Um, Once we get to our rational numbers, I'm going to lose things like the square root of 2. Once I get to my integers, I'm going to lose 1/2. Once I get to my natural numbers, right, I'd lose a number like -1. So that's what we mean by narrower and why we use that term to help describe those number sets, right? Because there's numbers that would get filtered out as we go down that funnel. One of the things, Lee, that you talked about were the natural lessons. And I just wanted to let families know that a lot of the times when we're thinking about looking at narrower domains, um, a lot of the times we've been thinking about this in terms of our challenge students or maybe those pre-challenge students. If you have younger students, I think you're going to find that a lot of those early booklets are going to be more accessible. So as we think about those students that are aging up and maybe entering the math map at a different domain, they haven't been with us all the way along. That's probably one of the places where wholesale changing to a different domain may be more appropriate. But for a lot of students, just looking at those earlier domains as a hint is enough. So the naturals are a great place for students to start if they're looking for an entryway in. We have had those available for download in the MathMap Companion in full size and in a quarter size. Beginning in April, we're going to continue to provide that quarter size natural. So it's 4 naturals pages per day because that has been shown to be really accessible for parents and for our challenge students. So that will continue to be a printable resource through the companion for you, that if you're looking for that narrower domain to go back and either as an introduction to the curriculum or as a hint, you'll still have access to that printable resource. If you're just looking at, hey, I want to be able to glance back and see, that's where I think the companion is a really great resource, because I can look at all of the domains and I could say if Lee has written a problem that's in booklet 19, page 10, and I'm not making a connection here. I can actually go into the companion and look at each of those different domains, and not necessarily to do the work, but just to go, oh, I see, that's what they were doing. I can now build this pattern up to what I'm looking at. So that's where the companion is a really great resource. As Lee said, you may occasionally have a student working on scratch paper, but a lot of times just looking and reading that page is enough to give you a hint. And it may be that it gives you, the parent, the hint that you need to then guide your student, or you look at it with your student for them to pick up that pattern through. So that's if you don't have younger siblings. Obviously, if you have siblings, right, then working together to look at the books and to see that transition through the domain is really ideal. And that's one of the ideas behind that one family schoolhouse, that us sitting at the table together for our math time, is that we can look at those domains and see the similarities and the patterns that exist throughout those domains to help both younger and older students, right, to put those pieces together. I also wanted to let people know, as Lee mentioned, sometimes you may just want one book. And if you email customer service, I believe, I'm going to say this, and Babs, you can correct me, but I believe you can email customer service and get just 1 or 2 books. It is not a cost-effective way. If you buy the book at a time, it will cost you a lot more than it will to buy the whole curriculum. But if you, for example, were just saying, gosh, this multiplication, we never really picked up multiplication with rational numbers. So I'm just going to get rationals 1 week. I'm going to get the multiplication week, and we're going to work through that as a scaffolding to get us sort of to where I think we need to be. You may do that. You may just pick a couple of books that you think you need to order, just those booklets, so that then you can jump back into where you were. If you find, as Lee said, if you find I've gotten into this for a couple of weeks and I want to go buy the curriculum and we're just going to do that whole narrower domain this year and save this this domain for next year, that's perfectly accessible. I love the fact that Lee emphasized that whatever you're using at home is what you bring into community, right? So just to reinforce that that was the whole idea, that it doesn't matter if your student is working through the fractions book, the complex book, the monomials book, right? If they're working on lesson 16, they're working on triangles and circles. They're looking at the same piece of art, examining the same trigonometry ratios, examining the same unit circle, looking at the same grammar of the topic, and they can all participate in community. I do want to clarify for our tutors, because we want to honor them, that they are going to be leading through the domain that's been developed for that level. So in Challenge B, our tutors are going to be leading with monomials. And the expectation is that students will bring monomials to class unless they are actively working in a different domain at home. So I just wanted to clarify that, right, that it's what you're using at home, not what do I have on hand at home, but what am I actively using at home that I bring to community that day. So, but thanks, Leah. I think that was really helpful.
Mhm.
Um,
I love your graph. I hadn't seen that before. I love that filter graph.
And
I
just to give
hadn't seen it. Yeah, I just made that up, so I hadn't seen it before either.
I was going to say, just to give an example, so last year I did have a student who brought fractions to class, and it actually was helpful to other students to see the fractions booklet because they were all using complex. I had one student that used fractions, and to let them see what the fractions booklet looked like was a good stepping stone if they were struggling. So they would go look at his page and say, "Oh, what does his, say?" And then we would talk about what the complex booklet says. And so I enjoyed, I know some tutors would be like, "Oh, I don't want them to bring something different." But I thought it was very beneficial to my class to be able to see another domain right beside theirs so they could see, if there was anything that maybe could help them if there was something they didn't understand.
And just to let everybody know, the plan going ahead is that beginning in April, right, we will have for sale all of the domains from digits through binomials, which means that those digital lessons that are currently available on CC Connected on through the MathMap Companion will go away. So if you want to have a digital version to be able to refer back to in future years, then now would be the time to go ahead and download those, because those will go away. And certainly as Lee mentioned, the Math Map has not been an inexpensive endeavor. It's been a big investment and continues to be a big investment as CC wants to provide that support through me, through Babs, through others. So it is important that we ask people to buy the curriculum, because it does support the work that we're doing. But for those of you who have enjoyed those digital downloads, those will go away in April. So I just wanted to make sure everybody was aware of that.
That's good. Another thing about having mobile copies, I mean, there's so many ways to save money and there's so many ways to study. So every family's going to have to figure it out for themselves what works after, they've purchased the first book and have given it a good try that year. Um, but I want to remind folks that, for those who are actually studious, we always have multiple books around us. So, for example, in our Bible study, good Bible teaching is that you use scripture to explain other scripture. That doesn't mean you don't go buy a commentary or a thesaurus or Bible dictionary, but you're flashing back to, Isaiah to see why Jesus said what he said in the New Testament. You're going back and forth through various books. And so if you have a few students, like Andy has indicated in her comments here, they can look at each other's books. And like Bab said in the seminar, if you have only one child at home that's using the math map, you might want to just go ahead and buy, say, depending on their age, one of the levels that's 4 or 5 domains narrower, just to have as a reference, you know. So, but you don't have to do that. It's just a suggestion.
All right. So let's go ahead and take a look at this question that we got from a mom. Assuming we've read the important instructions, because they are important, as we've all discovered, how do we know when we really need to spend more time on a particular problem because it's important versus when we can give it less attention, or how, right, this idea of this is on level, so my kid needs to be able to get this,
Mhm.
those kinds of questions. So I know I have some ideas, but Lee, what would you say
Mhm.
to this mom?
Well, I guess I would position it differently because I believe just like piano practice and sports practice and painting my living room, that if I keep at it and spend time on it, I can get it. Now, there is such a thing as bad practice. And that's the one thing. So you don't want to spend a lot of time on bad practice. So there's kind of this balance in this. Um, and so there's not really a way to know any individual problem if it's the most important one, except for like we opened up with, look at the tops. Look at the main images, words, and symbols that are on the page. That's always the most important thing when you're actually digging in. But before that, the most important thing is this skill set of being able to read the math. And so with each child and each concept, it's going to vary. There's not like there's a single way to know. For some of your children, it's going to be timing and sitting still and hand-eye coordination. That's important. The other ones are, reading the instructions. We were just talking about like 11, 18, 25, and 26. One thing you've done with us a couple of times, Kirsty, on the math in the Math Book Club, it has said, can we just say out loud what's in front of us? The curve's going up. There's an X at the end of the axis. Like to us, those are the important things because as people who want others to love mathematics and be good, enjoy it and be good at it, we know it's looking at it really carefully that helps you. So it's not necessarily even the instructions, though those get overlooked also by us. So that's kind of a long-winded way to say that besides the tops, we've not delineated something else as being more important.
I think maybe what might help this mom, in addition to what you've shared, which is great, is that first year through, I wouldn't worry about missing things. And I think that that's maybe when this is the biggest concern is, oh my goodness, what am I going to miss? Unlike a traditional math curriculum, right? If you look at a traditional linear curriculum, third grade is when they teach percents. And fourth grade is when they teach negative numbers. Right. And I'm making that up. But if you didn't do it then, there's this chance you might never really see it again. Right. That there's these little nuggets they put in. I was talking to somebody today and they were helping somebody with pre-calculus and they were doing this short little unit on linear regression. And then they will never do it again. All right. And so that creates that anxiety of I can't skip something because I'm not sure what I will see or what I won't see. And that's one of the issues with skipping between different curricula because one curriculum might do similar triangles in ninth grade and the next curriculum does similar triangles in 10th grade and then you never see it again. And so if you did curriculum A in ninth grade but curriculum B in 10th grade, well, you just skipped that whole concept, right?
Mhm.
So the math map isn't like that. So where you've had that experience in the past, the math map says you're going to see this almost too much every year. Because as Lee has written the curriculum, one of the things I'll say is, well, we did that in this domain. They should know that by now. And Lee says, I don't want to make the assumption that anybody knows anything. So she repeats things year after year after year. Now, that doesn't mean everything, right? Every single problem gets repeated, but there's enough that there's very little that you only see it once. I don't think there's anything you only see once. But the things that the why or the how are actually shown in multiple years. So the chance of you missing anything, if you stick with the math map, is, I would say, almost infinitesimal. It's so
Mhm.
small because everything is in there every year.
Mm. Kirsty,
So
you know what? I would say something we don't ever talk about is if you're concerned about missing a section and you have the companion, let's say you're in complex or monomials, look ahead to the binomials and the transcendentals, or I mean expressions and polynomials, and see what's there. And that might make you go, oh, we really will see it again. So go ahead.
yeah, no, and that's a great point. And I think that that's where the onus on the parent is not to say what's important and what's not important. What do I skip and what don't I skip? That we don't expect you if you're not mathematical yet, right? And that's a yet, right? If you don't have that confidence yet in leading mathematics in your home, what you are confident in is being able to teach your student and guide your student. And instead of worrying about what did we miss or what didn't we miss, I would say the goal is to start keeping a note for yourself. So there's a few different ways you could do this. My favorite, and I don't know if I actually ever put this in the companion because it's somewhat probably works with my brains and it might not work with anybody else's. But if you think about the math map and you have a square, and each square has some domain, say the naturals, and some lesson, let's say 24, right? If you keep one math map for your student, right? Here's my square. You could divide that, and say, okay, yeah, we got pages 1 through 4. We got that. Page 2 never looked at it. Page 3 we never looked at it, but page 4 we did, right? So you come up with your own system, but you could just use some kind of a little visual system on that math map, and you keep that, and then all 390 weeks of math instruction in your home, right? The next year I could look at this.
You mean 390 pages? You
No,
said weeks.
yeah, it is. Well, 30 times 13, it is
Oh, that's
weeks.
what you. Oh, over the entire grade, all the
Yes,
years. Yeah, yeah. Okay, go
right.
ahead.
Yeah, I know. Right. There you go. This is a checklist of how long you have with your student.
Yep.
So the next year, when I get to, all right, if I look back and I go, oh, I did pages 1 and 4, I really want to make sure this year that I focus on pages 2 and 3. Right. And then that's just one way. There, that's just me. But you could also use your charts, right? So you as the parent, not the student, but you as the parent could make notes on those charts. We give you copies of the charts every year because we want them to be a used resource, not a pretty book on the shelf. Right. So here's my charts, right? And they've got the different sections like this. So maybe, yeah, we got this section. So maybe I put a green box there and I put a green box here, but this one, like I didn't understand it, so I'm gonna highlight that one red. Well, next year, when I come back, I just look at that chart and I go, okay, last year we didn't touch that section on the chart. The problems that related to that, I was just like, not that is beyond me. So you know what? As a parent this year, I'm going to make sure I go watch the book club on that, or I'm going to email the help desk on that, or I'm going to look at a different domain, and I am going to prepare to lead my student through those exercises this year. Right. So notice that the goal is not, oh, I know all of the math and I know what matters. The goal is that the math map gives you a way that you can keep track of what was done or not done. Finally, I mean, you could keep your lesson pages, right? So you could keep all your booklets and put little flags on the pages of things that you didn't do. And so again, next year I get to booklet 24 and I look at page 10 and we left it blank last year. I'm going to make sure that we complete page 10 this year. So we've gone from like a lot of information in a little space to keeping your whole curriculum from year to year. But I don't think you can do that with any other curriculum. That we give you so many ways that you can record keep so that I don't have to worry about did we miss this or not, because I can look back and I can go, oh yeah, we didn't do this. I made a note last year that we struggled here. We're going to spend more time on that. And that's what homeschool parents really are good at. Right? That's what homeschool parents are really, really good at. And so lean into your strengths and keep track from year to year. And just as Lee said, right, we don't want to have bad practice. So bad practice would be every year we just do the pieces that feel familiar and we never wrestle with that problem on page 4, right? Sometimes we need to go and wrestle with that problem on page 4. It doesn't have to be every year, right? But after we've done it a couple of times, all of a sudden we're going to go, oh, well, it's not that hard anymore. Um, and then I think talking about this idea of things being on level, I really loved what Lee said about, again, you know your student best, right? I remember talking with parents, when I was a director and a support representative, and I would use foundations presentations as an example. My first year that I tutored, I had a little girl in my group, and she would go and literally hide behind her mother's legs under her chair every week at the beginning of the year. By the end of the year, she would stand in front of the class and show something. She still didn't talk, right? Was she doing a presentation? Maybe not really, but was that growth to go from hiding underneath the chair to standing in front of the room? Absolutely, right? So for your student, just sitting down at the table willingly at the end of a math map year might be a win for you. And I think that that's where, as parents, we need to really celebrate the freedom we have to be the ones that assess our children, right? And recognize like that was a big success. So if we can pick up there next year, we're going to really learn something, right? And so this idea of being on level, right? When we think about testing, I know I've talked about this before because most of us live in a state where you have to have some kind of testing. Those tests were never designed to actually monitor how well your student is doing. And the people that write those tests never really sat down and said, well, what is developmentally appropriate for a 9-year-old? They were somewhat arbitrary tests so that schools could be compared to schools and teachers could be compared to teachers. And so take those results with a grain of sand. If you use the same test from year to year and you see growth, that's great. But that's not your be all and end all, because that test was not designed to really monitor what matters to your student and to you in your homeschool. So I just want to say that when we think about things being on level, right, that to take that with a grain of salt, the testing, because every child is going to be different. And what you want to be able to see is, are we growing? So.
Okay, thank you. So next question.
On week 6 of page 10, there is a problem here to convert from yards to meters. And so this parent wanted to know when her fraction student encountered 32.70 divided by 1.09, how should she be helping her student with this problem?
Yeah, I like how she asked it. Am I teaching them long division or is there an easier way? And there really is an easier way. There's two easier ways. The one's not so helpful, but it might be, and that is to pull out a calculator, right? You could do 32.70 divided by 1.09. And then when the child comes up with 30, that's where the hope would be that you go, oh, 30, that's a simple number. How come I didn't see that? Right? That's where that familiarity with your multiplication tables and the kind of numbers you should expect, and is the calculator in the right or doing the right math, the correct math. So I just know that even when I do like long division problems or I pull up my calculator and I get something that's a simple fraction or a whole number, a natural number, integer, I look at the problem again and go, how did I just not do that in my head? Right now, I'm an adult doing that. So what I would do in this one is say to them, okay, let's look at the numbers. Remember that seeing and paying attention. 32.7 and 1. How many ones go into 32? 32, Mom. 30. Estimate, right? Wait a minute. Are you seeing a 9 and a 27? Do you know something about 9 and 27? And so knowing your multiplication tables really well will make that stand out. Oh yeah, that's 3. Wait a minute, 3 times 1 is 30, and 3 times 9 is 27. I see my 3270. So what we tend to do is if we can't calculate quickly because we're used to worksheets, we don't stop and say, first just look at the numbers. And so that was why there's not a lot of problems like that at this level. There's very few of them, but they're within word problems or these unit conversions. And the goal was to, with a few of them, not a lot of them, most of them are very common units they're used to, reducing, is to make them look at it and go, wait, that's just 3 times the number, or that's just 5 times the number, or that's just 10 times the number. They will have done a bunch of them before this level if they've gone through the decimals and then hit the fractions. So this is again where, like back down in decimals, the problem's easier. It's a more recognizable number than 32.7. So that's what I suggest they do, is talk about the numbers in there before they even tackle it. And then use a calculator if you don't see it. It's okay.
Yeah, I love that because that was exactly what I was thinking. Or you could even look at the solutions page if you don't want to go to a calculator. And then have a conversation about the relationships that you see there.
Yeah. Yeah, because it's not a properly taught. There's so many ways to do that problem. You could do long division like she asked, or you could write 32.70 over the 1.09 and see if you can reduce a 5 out of it, or a 3, or a 4. You would find out quickly that that's not particularly easy in this problem. But that's a strategy you could do if the number is 525 over 25, or 52.5 over 25. So the other added problem, which we didn't do at this level, is there's no decimal like to move around to do that problem this way. We tried to make it so that they're just working on seeing the relationship between the two numbers. So,
Well, great. Thank you.
mhm.
All right. So let's look at a similar case here where the question is from week 6, page 14 of fractions and comparing hectometers to decameters.
That's a head scratcher. I like that she said scratch paper. I thought, yeah, these are head scratchers. So what I have to do every time I do these problems, and I've been doing conversions forever, I have to pull out this chart, or the one that we have. There's a practice chart in one of the lessons, and I fill in the numbers and I fill in the units and I match up where I move to. That's one way to do it. The other way to do it, of course, for an older child is to use scientific notation and to rewrite both of the numbers and see if that helps you to do it. So once again, most of the problems with these unit conversions like this are pretty easy. But I think there's like 2 in each level where we're like saying, okay, really try to look at the chart to see if you can figure out how to move the decimal. And look, we didn't even make them do the math. If you can figure out that hectometers are more than decameters, you probably know it's greater. The 1.8 and the 8 don't even mean that much. But that's once again at an adult level of understanding where you're so familiar with numbers, you can say that to yourself. And that's one of the things, Kirsty and I, why we've agreed to just do so many repetitive problems. And there's certain numbers that I've been told I over practice, like we keep seeing these numbers. And I'm like, that's right. There's got to be a handful of numbers that you know so well that they go with you. And the only way of doing that is to keep using them in the curriculum. So you see the 10 and the 2000 above it? Easy, right? But every now and then we throw in some ones that require slow down and see if you can go figure this out.
Yeah, I think that was a really great just slow down, right? And think about it and look at hecto and deca. And again, you don't have to do all of the conversion, right? But thinking about 100 meters versus 10 meters, right?
They're already bigger.
Already bigger, right? And
Mm-hmm.
and so I think the one of the things when Lee and I first started talking was about helping to develop this number sense because we've been so ingrained that everything is calculate, 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 and that we don't stop to think about, is this a reasonable number? Do I have to do all the calculations, right? If it's a comparison, if one of them was negative and the other was positive, I don't need to calculate. I know my negative is going to be less than, right? So stopping and thinking about, right, if it was 1 hectometer and 8 decameters, well, one is still going to be bigger. So I don't even have to worry about the 0.8. And that's where we're using our language and we're having a conversation about the math instead of just computating, instead of just calculating. We're having this conversation and really thinking. I think that's really important.
Something that the brain does not like is this kind of problem because the 10 and the 2000 are pretty easy and the point 0.5 and the 0.25 are pretty easy. So the brain just wants to do it because it knows what's going on. And so by throwing something like this in, it makes the brain stop using what we would call your long-term memory, which is the one that wants to keep moving, and then work with your short-term memory. And people who seem very smart, that have copious language or quick at things, it's because they spend so much time working on their short-term memory that it fills their long-term memory. But things that are too easy, your short-term memory won't engage with.
All right. Thanks, Lee. All right, so our next question that's been sent in that we wanted to go ahead and talk about and address is this idea in the constructions unit of there seeming to be missing steps. And I'm gonna answer this one, and then Lee, feel free to chime in. The goal is to see this progression for the same constructions. So we're not asking students to necessarily to construct something new each year. They're the same constructions from year to year, but they're not actually going to be unleashed to go and construct it entirely on their own until the upper challenge levels. So we know that even though our expectations of our students are sometimes higher, that our 11, 12, 13, 14-year-olds are still developing those skills, those fine motor skills, those hand-eye coordination. And so we're not expecting them to necessarily do all of these constructions themselves and run the risk of being frustrated. Instead, we're asking them to read through the instructions that are there and then finish a construction. And because things are written bigger for the earlier years, steps have to be omitted in places. They just, not every step is shown. So this one here this is the question. This is the one that has the question. That there is a step, a quote unquote step that is omitted between 3 and 4, right? So in here, what happens is that you go back and use DE1, which is our perpendicular bisector. So this is
Right next to it.
which is right next to it. So
Yeah,
that's not written in there again, because Lee is just showing some key steps. She's not trying to show every single step every year until we're in those sort of upper challenge years. But if you are looking at this with your student and you look from left to right and you kind of go, okay, well, how did they get that? Because notice this one, here's our skills of learning, right? If we compare the solution there to the solution here, they look awfully similar, right? And they're really close. What's different is that point P. Well, the A and the B are both there. So now I look up and I go, maybe, right? This may not happen, but I want to think about, okay, well, how did they go from this step to this step? Oh, look, here's my A and my B and my segment, and now that part looks like that. So using our skills, our learning skills, our comparison, right? Attending and comparing is maybe going to help us to go, oh, this is what happened, even if it's not explicitly stated. So we do want to acknowledge that not every step is shown for every construction yet, because the expectation is just that they're tracing, right? They're tracing down here. They're practicing with those skills. But for those students who are reading through and they're going, well, something feels like it's missing, compare, attend, and see if you can figure out what went in between. And you may notice it was what was right next to you. Did you want to add to that, Lee?
No, I just once again that's why the companion exists too, because in the companion you can see where the steps are going to lead the students. So if you feel like something is missing, so that's the looking forward versus looking if you're struggling at the binomials level, you can look back. And also through the narrowest few domains, the students aren't expected to use any tools. And then in decimal fractions rationals, we encourage them to use the tools, but we give them really big pictures to draw. And then here at this level, we're encouraging them to use the steps that need the tools, with sometimes just the final result at the end of it. So they get the tool practice. Because that's, that all of them all of them have pretty good hand-eye coordination by the time they're, 11, 12, 13 years old. And then if it starts in binomials is where we do every single step.
And
So
I
they
just
get 3 years of it, 3 years of
I was
every
just going to
step.
point out that the videos for all of those constructions. So if you want to see every step acted out, if you go in the companion and you go to the charts, not the lesson pages, you have to go to the charts. If you click on each of those constructions, there's a video for each of those constructions because we know that sometimes the videos are a little bit easier when we're talking about all of these tools. So that resource is there if you had not yet found that. And I think this is our last question that was sent in. And this is related to, this is really for tutors, although certainly they're great questions for anybody. This is related to the interesting integer worksheet that we provided for tutors. And there's some questions at the end of that worksheet that are sort of challenge questions that you can think about. And so the first one is how could a number be expressed geometrically? And so one way, right, they say here an integer could be expressed as a rectangle or a square. And so if I mean, I could say 13 times 1, right? 13 is 1 times 13, and it's just one long rectangle, right? A number like 6 could be 2 times 3 gives me my 6, right? So I can look at things geometrically. I could also think about a number like 10, right? I could express it as a triangle. Or could I arrange my dots into some other shape? So there's no right and wrong answer here. This is really just trying to connect this idea of I've got a number, what would it look like geometrically? I could always say if let's say the number was 7, well, I could draw, I'm going to do a very bad job here of drawing a heptagon, right? So I could draw my heptagon to show 7 sides. So there's different ways that I could interpret this question of expressing something geometrically. There's not necessarily a right and a wrong way, but it's encouraging us to start thinking about what does that number look like, right? If it was expressed with figures instead of just a numeral.
So Kirsty, should we say the units? Do you think that would help so that the first one's 1 by 13 cubes and 3 by 2 cubes, but 10 dots, 7 sides? Like
You
we need
could
to add that unit so we know what we're looking at.
you certainly could do that. There's a lot of, because I could say this as, 113 block, or is it one, right? 13 one blocks. There's different ways we could talk about that. So yes, you could add units. That may help some people to see this as units, thinking about things geometrically. Then related to that, how could a number be expressed algebraically? And so again, that could be taking, if you remember in lesson, I think we did it in lesson 12, and I'm not sure where else it shows up.
Yeah, 12. Yeah.
Right, where we could take if x equals, we look at this, right, and you say, I've got x squared and then 3x and 2, something like that, or x plus 1 squared. If we had this was x plus 1 and x plus 1, we did various geometric expressions of algebraic expressions, and then you saw where we let x equal a number. So you could do that, or you could say, right, 13, well, if x is 12, it would be x plus 1, right? Or it could be, if x equals 12, it could be the first power of x plus the 0th power of x. Or if I said x was 3, maybe it's x squared plus x plus the 0th power of x. Right? Did I do that right? 9 plus 3 plus 1. Yes. So that's what I was thinking when we think about something algebraically, right? And students could say, well, I'm going to let x equal 10 and y equal 3, and then 13 is x plus y, right? It doesn't have to necessarily be something that is as thought-provoking as this example. It could be something that's a bit more straightforward. But it's, again, the goal is how can we just be asking our students to be thinking about this? Now, with an older student, I might encourage them to think of something like 35, which is 5 times 7. And I might say, well, this could be x plus 6, hang on, and x negative x plus 6. Would that make it right? If x equals 5? No. See, this is why you shouldn't do things on the fly. Because I would want something, subtract something and I get 5, and add something and I get 2. So if x is 6, there we go, and I have x plus 1 and x minus 1, there we go. So x plus 1 and x minus 1. I knew the 6 had to be in there somewhere. Now I could say I'm looking at the difference of two squares, right? Or something similar, or conjugates, right? So now I can start talking about, well, what does this look like? What is this close to? How could I figure this out? So my older, right, maybe a challenge 3 or a challenge 4 student might come up with something that's a little bit more thought-provoking, like this example, right? How could I come up with this, right? In what different ways? There's an infinite number of ways I could express something algebraically, right? So I'm just throwing out different ideas here for ways that
Let me kind of clean it up with a simpler example. So if you know, you take the number 356, and you know you can take place value blocks. You can take 300s, 5 10s, 6 1s. So you know you can go in that direction. You can build a visual geometric version of 356. Well, if you go in the other direction, you say, well, 356 algebraically is 3 times 10 squared plus 5 times 10 to the first plus 6 times 10 to the 0. So now you've expanded it. Well, if those 10s get replaced by an x, it's now an algebraic equation. So the algebraic equations have to be able to be represented by physical blocks, by things in real space.
And notice all of these, when we say algebraically, we're talking about specific values. So we're saying x equals this, but here's some expression of x. So we're not saying, right, we couldn't cover up this part and just leave this part, because that would that would be a whole range of numbers, right? There'd be an infinite number of numbers depending on X. So when we want one specific number, we have to say, what does X equal? But using that, we could write this. So just different ways of looking at that algebraically. And then when the question here was a dimensional measurement, and really a dimensional measurement is something like I have 5 feet or 16 feet squared or 3 gallons, right? And so most of our integers, right, about half of them would work really well as dimensional measurements. Which half would not be good dimensional measurements?
Yeah, say that again. I missed the beginning of the question.
So I could have, for example, I could have 5 feet. I could have
Oh,
17 meters squared. I could have 3 gallons. I could have 492 inches. I could keep going with an infinite number of ways that I could measure a dimension. What kinds of numbers do we not get when we measure something?
oh, negatives.
Or
Negative.
negative.
Yeah.
Yeah. So when we're talking about an interesting integer, right, those are the numbers we would exclude from being a dimensional measurement.
Mm.
Now, we could also think very narrowly and say, okay, well, any number could be a linear measurement. But if we're thinking that the number that it's based off of, that its base was also an integer, we might be thinking, well, perfect squares would be an area, perfect cubes would be a volume, right? If their base was also supposed to be an integer. So we could think of that narrowly as well as widely. But those are some of the things that you could think about when we talk about this. And of course, as this tutor mentioned when they sent in this question, she said, I know that this isn't a script or it's not a I have to type of exercise, right? These are just some suggestions. So if you feel confident having these conversations with your students, have them. If your students are ready to talk about expressing them algebraically, have that conversation. But notice we're not really going into algebraic computation until monomials and then really binomials. So these questions were largely included more for those students that are going to be in those upper challenge years. So I just wanted to point that out for those tutors that are working on this. Any other questions on this? All right. And then this is a great, thank you, Yating. So we got one more question. So a parent saved the I-4 pages as assessment for the first 14 weeks. The result was not ideal since there's a retention loss and the student is in challenge 1, so he has 4 more rounds. The mother is worried that the amount of retention for just 4 more rounds of the math map should she supplement so that her student can be prepared for a college entrance exam. So here's my yes and no. Because the domains that have been released so far, the student is in challenge 1. Yating, are they using a binomials or are they just using?
They're using binomials and then even complex at home, but
Okay. So they're in a pilot community?
no, I think what it is that when complex first came out, they bought it, but they weren't in the community, and now
Okay.
they joined the community, and now they're in monomials. Yeah.
Okay.
Yeah.
So even so complex and monomials is not going to give you a lot of computation practice. They're going to start getting more computation practice in binomials and then a lot more in polynomials. So yes, 4 more rounds is probably going to make a big difference to that student, right? Every year, I think you're going to go, okay, I got this much in complex, and then I maybe grew this much in monomials. But each year, I think you're going to see, right? As you see it again and again, you're going to retain more and more. So there's a potential here that it could be enough to prepare the student for the college entrance exam. I don't think that the I-4 pages, the careful calculations pages, is a good assessment for that necessarily, especially if they haven't been kind of reviewing those ideas, not the first year. For a student who's in challenge one, and sort of, I'm going to kind of, they're kind of a year ahead of where sort of everybody else is. So if they haven't, they may want to add in a little bit more algebraic practice, or test prep, right? So because they're in monomials, they're going to get binomials in challenge 2 and maybe polynomials in challenge 3. So by the time, if they're testing early in challenge 3, they may or may not have the practice, the algebraic practice that they would have had they been able to be already, if they were in challenge B, they'd have that extra year. That would make a big difference. But here's what I would say is, instead of worrying about supplementing to the math map, I would say if you're preparing for college entrance exam, I would do test prep for that exam, right? Those exams, again, just like I mentioned earlier about testing, if you think about the fact that these tests are not necessarily individual student achievement tests, right? They're very global in their scope, and the way that they ask questions are going to be different. I mean, there's the politics behind textbooks and tests and all of that stuff, right? We are outside of that. So I would really say, if you think, if it matters to you to do well on this specific college entrance exam, I would get a book that prepares your student for that college entrance exam, because it's not just going to go over the math concepts. It's going to go over, how do they ask the questions? What are the strategies, right? We're taking a student from a classical environment where they're encouraged to think through, right? Use their skills, compare, do all of this advanced thinking, but your test is multiple choice. And if your student has never been encouraged to go through a multiple choice test, there are strategies, because it's timed, right? So there's strategies for dealing with a multiple choice test that are not about learning, right? It's about, how do I get through this quickly and efficiently? And so there's going to be some disconnect between teaching your child to think thoroughly and having them go through very quickly on a test, right? And that's a good thing. We don't want to train our children to just think quickly, right? We want to train our children to think deeply, not just quickly. So that's where I have started to really encourage, if it matters to you to do well on a particular test, buy the test prep booklet. The math map content is going to prepare you for that, but take some time. Don't replace your math work here, but take some time to prepare for that exam. And I think that is going to be, right, it's a piece. Don't let that whole exam guide all of your math time. Just make that a piece of what you're doing. Just like when you're going to get your blood work done, you fast, or you, right? We all know, right before you go to the dentist, those 3 weeks before you go to the dentist, you floss. So that when they go, oh, do you floss regularly? You go, yes, I do, for the past 3 weeks, right? Right? You prepare for a
Yeah.
test.
Oh gosh, we have to do all this prep work. Get worse. I don't floss. Yeah, but thank you. It's very good. Thank you. It's very helpful.
No, I really do floss all year long. Yeah. Here I am, outing myself nationally that I don't floss every day. Don't tell my dentist.
Appreciate it.
So next week will be our last Q&A, so feel free to send us in your questions. Last week we talked about the coming flashcards. This week we talked about the coming manipulatives kit. And so next week we'll talk a little bit about the domains that we're releasing, and we're also going to talk a little bit about the idea of being a lifelong math learner and what does that look like from Scribblers all the way through the master's program. So if you've got some curiosity about the master's program, it'll be a great week to come and have your questions answered, because we're excited to talk about that using some of our time next week. So any other questions before we jump off? Well, thanks everybody. I appreciate you all showing up this week. I hope that it was encouraging and helpful.
Always. Thank you, Kirsty.
Thank you.
And thank you, Babs.